Hari Om. In this video we continue with the thermal expansions. Now we are going to obtain equations for different types of thermal expansions. Okay. So first we consider linear expansion. Linear expansion. For this I consider a thin long wire of length L, and if I heat it through delta theta increase of temperature, then it is found to expand through a very small portion, that is delta L. So L is the original length, delta L is the increase in length produced by the increase of temperature delta theta. Now we use the conclusions 1 and 2 to this case. That first conclusion says the increase in length is directly proportional to original length. So here the dimension is length. So increase in length directly proportional to original length. And second condition says that increase in length is directly proportional to increase in temperature. Therefore, the increase in length directly proportional to original length into increase in temperature, or delta L is equal to alpha into L into delta theta, we can see. So this we can fix it as the equation for increase in length. If delta theta is increasing, then this is increasing length. If this delta theta is decreasing, then this is contraction in length. So the same equation you can use it for expansion and also for contraction. Okay. Now what is alpha? Alpha is called the coefficient of linear expansion of the material of the rod. And the particular material, this will be having a definite value. Suppose I take copper, will be having a value, iron another value, steel yet another value. So this is a constant for what you call a particular material. The idea you can get it from logarithm table. There is a data table is there called logarithm table. In that one you can search for finding out the coefficient of linear expansion of different solids. Okay. So how to define this alpha? It's done from this particular equation that alpha is equal to delta L by L into delta theta. So using this particular equation, we can define alpha as the ratio of fractional increase in length to the increase in temperature. Fractional increase in length divided by increase in temperature. And therefore, alpha will be having a unit which is per degree Celsius or per Kelvin. Okay. Inverse degree Celsius or inverse Kelvin will be the unit of coefficient of linear expansion. So this is the things about what we call linear expansion, and sometimes you will be expressing this in terms of what you call initial length and final length. That means L initial and L final. So initial length and final length, if I assume, then there will be initial temperature and final temperature. Then I can express this equation as what you call LF minus Li. This is the change in length, will be equal to alpha into L initial into theta final minus theta initial. This is the equation we can have, and finally I get final length is equal to this initial length will be going over here. So initial length into 1 plus alpha into theta final minus theta initial. There is an equation like this is possible. So here we are finding the final total length compared with the initial. So both these two types of equations, this one and also this one, you must be remembering. Okay.